Okay, we're going to start with lecture 1. So lecture number 1 is going to be an introduction to Objective-C as a language, comparing it to C, C++, other languages you might be familiar with. It's completely object-oriented, so there's a lot of similarities between C++, Objective-C, and Java, actually, which are three pretty much comparable programming languages. I like to compare the languages because then it gives some people some frame of mind in terms of how the features are implemented. What do we have here? You're looking at the PowerPoint lectures. There's not too many of them for this course. I'm not going to show you PowerPoint all weekend, although I will show you a little bit. What you're going to primarily be interested in here is called the source code examples. If you click on the source code examples link, and this is for people who want to follow on their computer, because sometimes the screen isn't really as clear or as focused as you'd like it to be. Plus, if you want to make it more interactive, you can follow along on your computer what I'm doing, and you can basically, just as I said that the internet was working, I'm clicking on the link and nothing's happening. So anyway, in the source code examples, if you can get into that link, we want code 1 and code 2, which are going to be in lecture 1, lecture 2 examples. Okay, I see. As soon as the tech guy leaves, we lose the internet. So, all right, well then we'll plan B. If you don't have this one is lecture 1. When it comes up, hopefully you downloaded lecture 1 already, maybe not. If not, wait for the internet to come back up and we'll do you'll be able to download lecture 1. I'll hold off a little bit on the source code until we get our internet access back. If you do, go into source code examples and get the first 2 zip files, which are going to be lecture examples for lecture 1 and also for lecture 2. So I wish I could show it to you. These source code examples, no, they're not working here. All right, Objective-C. Implemented a set of extensions to the C language. So we had C. Everyone likes C. We're very familiar with C. Maybe, okay, people are shaking their head. No, I don't like C. If you don't like C, you're not going to like Objective-C either, seriously. But we had C as a base language, and then we had C++, which is the Windows route to everything. Or I shouldn't say that, but it's primarily done on Windows operating systems. And it's .NET right now, C++, and Visual Studio is high supporting of the C language. And then we had Objective-C. So it's kind of like the Mac and the PC world. So Windows is the C++, Mac is the Objective-C. You're wondering, well, why in the world do we have 2 separate languages that are both accomplishing the same thing, but they're for 2 different platforms? And long story short, they both have different design goals in mind. C++ was primarily for Windows, MFC, Microsoft Foundation class interfacing, and it was kind of a side effect. It was sort of in hindsight they went, oh, maybe we should make a C++, maybe we should make an object-oriented version of C. So we can program in C, but then we have object-oriented features. So that's what essentially the driving factor around C++ came out of it. The goal was to make an object-oriented version of C. So then the C++ people continued on with their development route. And then at the meantime, on the other side of the fence, on the Objective-C side of the family hierarchy here, they went, well, we want a true object-oriented language. So they took Smalltalk, which was one of the original before Java, before most of the other object-oriented languages. One of the original object-oriented languages was Smalltalk. They took Smalltalk and C and developed a better object-oriented version that's truly object-oriented. C++ is sort of a hybrid object-oriented language. Objective-C is 100% object-oriented. There's no hybridness about it. So the syntax is very similar from a C perspective, but from a C++ versus an Objective-C, night and day. Totally different syntax. Totally different way of allocating objects and using objects. So most people, if you can get past the syntax, you'll like the language. It's just like C++, it's just like C. And people go, well, how does that differ from Java? Java is a slightly different interpretation of object orientation as well. It follows more along the lines of Objective-C thinking. It's less C++-like. But it's made for a different type of platform, the JVM, so it's kind of a different programming style in general as well. You don't never get to executable code, you're always getting to bytecode with Java. With Objective-C, you're getting to executable code. So as a slide that kind of tells you here, in addition to C, a few more features based on Smalltalk, one of the first object-oriented languages. So people who like Smalltalk like Objective-C because it's very similar in terms of its syntax. So incorporate C, you get the benefits of C, and working with Objective-C, you can actually write C code. We'll do that today, actually. And then it's a simple language. Its syntax is small, unambiguous, easy to learn. There's our selling points here. And very dynamic, mostly dynamic. One of the most dynamic languages available based on C. So object-oriented programming. I don't have to tell you about the object, hopefully, but I'm going to review a little bit of object-oriented programming just so that, that sounds like me, so that you have a frame of mind, but you don't really need to know that much about object orientation to understand how to program in Objective-C. So we all have the objects. So what we're doing is we're creating objects, and our objects have 3 components to them: identity, state, and behaviors. The identity is the name of the objects and the role that the object's playing in the system. The states are the information that the object is holding on to, the variables, the fields. And then the behaviors are the methods. So it's just the same thing you get in C++, same thing you get in Java. Any object-oriented programming language has the same concept of the object. So what we're going to do this morning is take a look at how to program those 3 things. You know, how to create a new object, how to give it some data, and how to make the data work, which is the fun part. So we can also use C because Objective-C is based on ANSI C and is ANSI C compliant, which is why we can use GCC with that. I feel the air came on. It's kind of nice, actually. Although some of you people are going to start complaining about being too cold soon. All right, so what do we have with Objective-C that we don't have with C? Well, actually, let me have a poll of hands, I guess. How many people have worked with C before? So raise your hand. Exercise. Okay, good. So a good majority of the class is familiar with C. That's a bonus. How many people have never programmed in any programming language before? No, you have. You're in my Java class.
But I haven't really, I don't have on-field experience.
Okay, how many people have never taken a programming language course before? All right, good. All right. If you've taken a class, it doesn't mean you hadn't worked. I didn't mean like work as a programmer. I meant like familiarity with it. Okay, because then I know how low level to go in my descriptions. I'm going to go very high level because I'm going to assume you guys have experience. If you don't, and you're completely lost, there's a guy who makes a really cool book out there for C programming called, you know, I used to call him Deedle and Deedle. Someone corrected me and says, no, it's Didle and Didle. How to program. I'm going to attempt to use the internet again. We'll see what happens. D-E-I-D-E-I-T-E-L, Didle and Didle. How to program in Objective-C. Also, one of the books out there are going to show you more of the programming techniques. So here he is here. Actually, it came up. It's good. So the internet's now working again. He's got a lot of resources online. He's got a lot of tutorials. Oh, look at this. Comes right from the international version here. There's a lot of online stuff. It's a very popular language. You might have a need to actually do some self-study, is what I'm saying. Because this is not going to be like how to program kind of course. It's going to be more of a how to use Objective-C kind of course. All right, so if, well, now that the internet's working, let me go back into the BHacker website. I spoke too soon. You guys, did you guys get on the internet when I did that? Maybe that's what happened. Maybe it's just too many people on the internet. I don't know. Hello. All right, well, I wanted to get the examples because I wanted to start in with the examples, but I'm seeing that now I'm having issues. All right, so what I'm going to do is kind of just build you a program in Objective-C. But what I'll do is from the, if you can get on the bhacker.com website and go into lecture number 1, it's lecture 1 examples. That is the one that I would like to be able to show you right now. And I'm discovering that it's not working. Is it working for you? All right, we seem to be a bit spotty. As soon as the guy leaves, it stops working. Maybe instead of Nathan, his name should be Spot. Spotty. Yeah, okay. Hey guys, maybe you'll laugh at my jokes later. All right, so if I was able to download it, it would look like this. And if I were able to go into the file, I'll just bring up, because I want to show you Hello World right now. So this one's called hello.m. If I open up hello.m, I see the Hello World. And we usually, in any programming language, you usually start out with Hello World. Kind of get a feel for, what's the language about. So we see we have imports instead of includes. You can actually put include in there and it works. The difference between the include and the import is kind of funny. Import, people see that and they go, oh, it's kind of like Java.
Java and C.
Yeah, it's kind of like Java and C. Actually, you'll discover there's a lot of Java influence with this, but this came before Java. So Java copied from a lot of things. Actually, if you want to see a lot of influence, check out C#. That's Java and C++. Objective-C is really C in small talk. But people look at this and they go, import, isn't that kind of like Java? But you know what, this came before Java, so Java copied them. It's not really, anyway. But you can also put the include in here too. So the hash sign is this is a compiler directive, actually. And a compiler directive, and so we have two compiler directives actually in the language. We have the hash sign and then we have the @ sign. So we have, it's a shift 2 and shift, I don't know where shift 3 on the keyboard. Those are called compiler directives where we're speaking to the compiler. When we say import, that means take the code that already exists that's out there and link it in. Because we already have Foundation H out there. Foundation is giving us our Coca interface. Our Coca libraries are coming from Next Step, which is the library that we're using for the Mac. I mean, I'll go through the history after lunch, actually. But import is saying link to the library already exists out here in the library's foundation. Because we have foundation.o that sits out there. It's an object that sits, and we're just going to link to it. Include says go find the stuff that's in foundation and add it to our object. We don't want to link to it. So import is dynamic and include is static. They're both doing the same thing. You're using a library that's elsewhere. But are you going to put it inside of your object code or are you going to link to your object code? We like to use the import because this is dynamic and everything in Objective-C is dynamic. Everything in C++ is static. So in C++ you get include this, include that, include that. Because we're looking at a static. What does that mean? Well, we're going to take the compiled program, the .exe file that we have, we're going to put everything inside of it. So we have one self-contained unit. Java, we don't have that either. We have imports. Because imports, we're going to do it dynamically. So it means the same thing, believe it or not, in Java as it does in Objective-C. Same purpose. Accomplishes the same task as the include, done differently. So it's all dynamic versus static. This @ directive tells the compiler we're going to make something. Everything is an object in this language, so if we want to make an object, we have to say, use this @ symbol. So, okay, it's called an @ directive instead of a compiler directive. This is called the @ directive because it uses the @ symbol. This is, well, we're directing the compiler, we're making a we commonly see it this way, we're making a string. Why can't we just give it a string? Because we have to make an object out of the string. So, to say that we're going to nslog an object. Nslog is kind of an interesting thing. It's actually a log, a console log, but it does the same thing as printf and cout, actually. And we can use printf in here, actually. So, let's make sure that this actually compiles first. It may not actually. This is hello.m. If I were to change the directory to desktop, and then I think I have it called Objective-C, so let's see. I'm going to the directory where I have saved these files here. And this one's going to be in code 1. And I see I have hello.m. So the M is equivalent to the C, or the C++, or the .java. It's the main program. We also have a .h file that goes along with this. If we were to create a proper set of object files, we'd have a hello.h and a hello.m. But we're not really creating an object here. This is the simplified version of it. In C++ you don't have to have a .h and a .c++ either, but you see those in combinations. The .h is the interface. and the .m or the .c++ is the implementation. So in true object orientation, you have a public interface, and then you have an implementation of that interface. Same thing with C++, actually. So in Java, you have it all in one file, so it doesn't really compare with Java. But the .h has got a bunch of function prototypes, where we stick in there a bunch of definitions of some functions, and then we implement it in the .m file. And so we'll see at directives that say at interface, at implementation, where we mark the file what it is, and then we use them in combinations. So we're going to see that when I open up an XCode project. But for right now, I just want to talk about the .m and hello world. So if I typed in gcc space hello.m, I'm going to get a bunch of errors. Great. Let's just do it this way, actually. Hold on one second. I want to see the syntax. I have Python. I'm going back through my memory of my system commands, actually. Oh, here we go. CLang. So I went through my history of my commands here to show you how to get this to compile, actually. So when I typed in, and I kind of did that on purpose just to show you that it's not C. GCC works quite well with standard stdio libraries and things, you know, that are already in the environment. So if you're going to compile, and you're going to use the GNU step compiler on the Linux box, and you're going to, or through VirtualBox, you're going to do things the manual way. You're going to have to include the framework, and the framework you're going to include is Foundation. It's like including iostream.h or stdio.h. So what we did here, and you don't actually have to use CLang, GCC should work actually, but if I go GCC minus framework, let's just see if GCC works here, Foundation, and I go hello.m, I'm not even going to specify the output, you see that worked actually. So on the Mac system, through XCode, you get CLang. CLang's a wrapper that is a slightly different version of GCC. So if you type in GCC, sometimes there's an association that's built, it's a symbolic link, so it actually brings up CLang. Sometimes it does it the opposite. If you're trying to compile your programs on a command prompt, and this is essentially for the people who don't have XCode and are not doing this on a Mac, but you're doing it on a Windows system, you're going to use the terminal prompt, and you're going to use a Unix or Linux desktop kind of environment to do this with. You're going to be using GCC or CLang, depending upon what compiler you have installed. So if I type in GCC, this is a compiler switch for the framework, and the framework I'm including is called Foundation, and the file that I'm compiling is hello.m. So just the same way with C++ or C, if I were to compile this, I'd have a .o file. In fact, it would be a.out or I think it's called a.out. Let's just take a look. It should be in here, and it is. It's a.out. So a.out gets created. If I want to give it a name, I can go -o for output file, call it hello. And if I do that, then I'm going to have a file out here. If I look at it, it's going to say hello on it. That's your executable file. So a lot of Windows people get confused because there's no exe extension or anything on it, or .com or whatever. It's still an executable file. The way I would run it is right here, I'd go a.out. Just typing in the name of the file, and then I have hello world. What I did here is I put in a dot and a / because it's in the current directory. If you don't have a path set, actually I just sort of do that out of habit. If you have problems running it, in fact, this one probably won't run. If I type in hello, it'll say command not found because it's not looking in the current directory. So the dot and the / says run it from the current directory. And if I do that, then it runs. So now I have hello world printed out. Now if I go back to this file up here and I take a look at it, it's kind of redundant to have to tell the compiler that you're using the Foundation Network framework, but unfortunately it's because you're using a GCC compiler out here and you're bringing in the framework outside of GCC. So it depends on which GCC compiler you're going to use in your Linux solution. in terms of which framework, what you're going to call the framework. Sometimes, most of the time, it's supposed to be called foundation. There's a couple of different variations of this. Sometimes it's called Coca or Coca Touch, depending upon what you're programming in. So it might be Coca, it might be foundation. Look at the documentation that came with whatever it is you downloaded and installed. It's going to tell you what framework, but most likely you're going to have to include a framework in order for the program to become compilable, only because it's not C. And so the standard frameworks are not included. This is C. That's about as C as you can get. Integer main. So we got main. Main's a function in this context. Main could also be a method, depending upon the context we're going to use it with. This is the different part. It's called an auto-release pool. We don't actually need this anymore. In fact, if you have taken the Objective-C course about 6 months ago, actually you guys, I think you were in it. Were you in the iPhone class or in the Android one? When we upgraded to iOS 7 and we got the new version, which has just happened a couple weeks ago or about a month ago, no more anything reference counting. They took all of it out, which is exactly what I was predicting in the beginning. So in the beginning of memory management times for Objective-C, this is where Objective-C differs from Java. Java has automatic everything. Or let me rephrase that. This is where the older version of Objective-C differed from Java. Now Objective-C is just like Java. No more memory management crapola. No more automatic reference counting. No more auto-release pull, that's unnecessary. No more, you still have to alloc an init, and I'll show you that. But you don't, that's like new in the constructor. But you don't have to do any, all the options are now erased from even the menus when you go to create the projects. So they had this thing called reference counting, and this auto-release pull turns on auto-reference counting. Reference counting triggered the garbage collector to go clean up the memory. So in Objective-C, you have a dynamic language. Everything is created at runtime. Memory is allocated and deallocated by the runtime environment. That's where this auto-release pool comes into place. You created this pool. Don't write this down, actually. I see somebody writing. You're never going to use this. You're never going to need to use this if you have current software. But it's nice to know what it is, because like in this particular example, in every textbook you're going to open up, you're going to see this. So I guess you could write it down if you want to do it. So anyway, I didn't mean to stop you from writing. But auto-release pool was the old way of creating automatic garbage collection for you, or semi-automatic garbage collection. It wasn't really 100% automatic. Instead, what it did is it just cleaned up memory when it was no longer being used. You had to do it. So in the beginning, you had to create, you had to allocate, you had to retain, release, you had to tell the environment, hey, clean this up, don't clean this up. All this manual work. Java, we don't have to do any of that. So Objective-C became more like Java in the last version that just came out about a month ago. The current version, take it out of the situation. They basically, yeah.
But then if you do an alloc yourself, then don't you have to de-alloc too?
Nope. We have an alloc. We never had a de-alloc. We had a de-alloc, you're right. Then the de-alloc went away. Now we have to still do the alloc. We'll see that in the next example I'm going to show you. But we don't have to de-alloc. That's why they call it semi-automatic garbage collection. It's semi-automatic in terms of like, or I shouldn't say garbage collection, I should call it semi-automatic memory management. We have to allocate the memory, but we don't have to worry about deallocating it, because now we have sort of an automatic garbage collection that's going to deallocate it for us.
So you don't have to worry about memory.
No, you don't have to do that at all. So unfortunately, what ends up happening though is you're going to look at source code that was written more than about a month ago, and you're going to see alloc this, dealloc, release, retain, all this other stuff that's going to be in the code, and you're going to go, what in the world is all that? She never taught me about that stuff. So the problem is you're going to see it, although you may never even use it. So that's my instant way of telling whether or not you wrote this in this century or whether you wrote it in the last century, because I'm going to be able to tell instantly. This is kind of a bonus for me, because now I can tell how old your code is. What programming style are you using? You're using something that's not even needed anymore, which is still going to be backward compatible. It's still going to compile and run, but I'm going to instantly be able to tell you that this was probably written like at least 2 months ago, probably longer than that. Actually, you can tell real quickly, and I'll show you some examples, you'll be able to see it yourself, how old something was written in terms of, well, what kind of sense, what level of automation was introduced in the time frame that that thing was written in. Because it's evolved so much over the last year or so. All right, so back to this concept. This auto-release pool, it's old. You don't really need to worry about it. What we're doing here is we got to return just like C. It's a function main. This command line arguments is just like C. Takes in anything you type in, parses it out. Actually puts it into a character array. Unlike Java, Java puts it into a string automatically. C puts it in a character array. Objective-C puts it in a character array. This one happens to be a pointer character array because everything's a pointer in Objective-C. So, looking at Objective-C versus Java, Java is 100% pointer implemented, but the programmer never has to create a pointer. Objective-C is 100% pointer implemented, but we got to put asterisks in there. So it has the C++ syntax with the Java mentality. Like the Java mentality is that everything is a pointer, everything's dynamically allocated. You don't have any other choice. So they just pulled it out. You don't even know it when you're doing it. In fact, a lot of people would argue the opposite. Oh no, Java doesn't use pointers. No, the programmer never has to specify that it's a pointer, but everything is a pointer in that language. But the programmer doesn't know that. C++, you know that because you have the option of doing that or not doing that when you're using the asterisk. Objective-C, you have to use the asterisk. So why have all that extra syntax in there? That part I could never understand, but Java came after Objective-C, so Java took that same concept, got rid of the syntax, and said, well, we don't need all the extra syntax in there. So it's really very similar in terms of that concept. And you'll see that in a few minutes as well. But that's why this one's a pointer, because everything is a pointer in Objective-C. So, all right, so let's take a look here. I'm going to do something. Now, I think I compiled this one. It was called Hello, and I was working with Hello as well. We have a Hello World out here as well. If I compare Hello with Hello World, and you're maybe wondering, why do I have two different Hellos? Where is Hello World? Here's Hello World. I see I've got different generations. So this was the original. This one was the second generation of the garbage collection. The third takes this out completely. We don't have auto-release pool in there at all. In fact, the third one, I believe, let me just see if I can pull that one up actually. It's going to be in Hello World. Did I hear hacker? Yeah. Nope, that one's going to be the same. Okay, so I don't actually have the third generation, but we'll see that later. So in this version of Hello World, I'm contrasting all the memory stuff. Again, keep in the back of your mind, you'll never write the syntax, but you'll see the syntax. I just want you to be familiar with the syntax. You see this NS auto release pool, that's a pointer called pool, and then you see a drain pool down here, pool drain, and then you see, basically that's it. You see an alloc and you have an init in here as well. So this one is an object creation with an alloc, and then we also have an initializer that we're going to use on that object that we created. And then we have a this is a method call, by the way, down here on the bottom, and that one is draining it, which is kind of another form of release. Gets rid of it. This is very, 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 very old. Old. This is the original. This is part of the original syntax. Then we went to this syntax over here with this auto release pool. Now we don't have to do any of this. So when you see it, if you see that, that's a very, very old example. This is a medium size. So now you know what you don't have to do anymore. Because what's going to end up happening is you're going to get a book, you're going to see something online, you're going to download an example, and you're going to say, what is this pool? We didn't work with pools. We haven't been draining any pools or opening up, or we haven't been doing any auto-releasing or anything. What's wrong? It's outdated. Long story short, so just keep that in mind. So what do we got here? We have, going back to Hello World, I can actually stick in here, imports, actually let's include IOStream, let's see, stdio.h, let's do that one here. Let me just test to make sure my compiler, actually I have to see if I know that my Xcode is going to be compatible with this. I just have to make sure that, good. I'm good on the command line as well. It depends on which tools for Xcode. It depends on if you're going to use, I'm only going to use the command line in the beginning. However, it depends in the future which language you're going to program in terms of which support you're going to need. Xcode, believe it or not, does not come with C installed automatically. You have to go in the properties and you have to actually install the GCC compiler if you want the command tools. So depending upon when you compiled it, you might just get Objective-C, you might get C, you might get Perl, Python, PHP, and everything else along with it. It depends on what you have installed on that system. All right, so for the benefit of the C programmers who like C, I'm going to write C code in an Objective-C program for you. I just included, so remember what I said about the include and the import? They both work. I included iostream.h, and then now down here in the bottom, I'm just going to do a print out. So I'm going to type in print, what is it, print line, or as printf, I have to remember C right now. Oops, and that's a function. Hello there again, printf, if I have this correct. And I see that I have the compiler, this is a text file that I've loaded up that is actually running in an Xcode window. So I'm getting my auto correction from Xcode. What I'm trying to do is demonstrate the point that GCC works with C, works with Objective-C, Xcode works with C++, C, and Objective-C. All three languages. And this is a .m file. If it's a .m file, you'd think it would be Objective-C. However, it compiles. So if I run it, this is hello. I say hello world, and I say hello here. What did I put in here? Hello there again. Here it is here. Hello there again. Maybe I should put a, hold on one second. Let me put a line return in here. Put some line returns in here. There we go. All right, so now I see hello there again being printed out, and then I see hello world. Don't recommend it, but some people get stuck and they go, oh, there's this C library and there's this C command called printf and I really like it and I really want to use it. Go ahead, use it. But know that you're programming in C. You're not programming in Objective-C. You can actually take a full C program and compile it in Objective-C. It works. But what language are you programming in? C. So you might as well use Objective-C, right? So Objective-C is very similar to C. In fact, in my Objective-C program, I can define variables and use variables and run method calls and do everything I can do in C. It's just the syntax that's a little bit different. So, all right, so that's enough of the command line. Unless somebody wants to see more of the command line, there's really nothing to it. You're going to use Notepad, or you're going to use a text editor, you're going to write your program, you're going to come out here and you're going to use a GCC or C-lang. C-lang is the other one. This actually works with GCC. So I can use C-lang as the command, or I can use GCC as the command, and the program compiles, as long as I include the framework foundation. And I can put C++, C, or Objective-C all in the same file. Actually, in Xcode, you can put C++, C, and Objective-C. On this interface, you're going to use C and Objective-C, no C++. Because you don't have it, the GCC is not the C++ compiler. So I think it's G++ or C++. But anyway, long story short, that's your introduction to the command line prompt. So past the command line, people don't normally like the command line. So let's look at Xcode projects. So we'll make hello world in Xcode using the GUI tools, because that's what people are mostly familiar with, or they like. So if you open up Xcode, you see this little window that pops up. If the window doesn't pop up, there's a menu option that allows you to bring it back up. It's hard to get rid of the window, but you can unclick this box here at the bottom. It says show this window when Xcode launches, and you'll get rid of the window. But I wouldn't do that because I like the window. The window kind of automates everything. Once I open up a project, we're going to see it in the right-hand side. So this is your orientation to Xcode as well, by the way. So I'm going to create a new Xcode project. In the past, I kind of like the new interface. So in the past, if you have an older version of Xcode, I will warn you, your screen's going to look significantly different. you're going to have different menu options. It's going to look more cluttered. I like the fact that they they slimmed this down a little bit. So I'm going to go in here and click on create a new Xcode project. And then I get this little template screen. It says choose a template for your new project that comes up. And I have, you see on the top I have iOS and I have OS X. And you're going to wonder, oh wow, I got some choices here. The same programming works on both. You learn it on one, you can do it on the other. That's why people like this actually, because you can transfer your skills over. Objective-C is used for everything. So let's go up to iOS. If I click on iOS, I see, and then we're going to do this after lunch, but I see I got a bunch of options up here. If I click on application, I see I've got a bunch of application types, a single view application, an empty application. These are just generic templates. If I click on the OS X, and if I click on application, see if I click on the OS X I get everything. Click on iOS you get everything. But you really have 1, 2, 3 different categories. So all these subviews are doing is giving you the smaller category. So I see this is everything. This is just the application types. Let's write a command line tool, which is going to give us a command DOS-based application. So click on application of OS X, command line tool, click on next. Now this is kind of like where people are going to go, isn't this just like Java again? We don't have packages, but we have packages. So we don't have a Java package, but instead we have this thing called a company identifier. I put in itu.edu. And this is actually changed for the wrong project type. It says C++ in here. We don't want to write C++. We're in here for Objective-C. So you'd think that it would say Objective-C in the menu, and it doesn't. What we really want is foundation or core foundation. If I pick foundation, isn't that like the framework foundation from the command prompt? That's all I need for the command prompt is foundation. If I had core, I'd get coca.h in there too. And I get some of the other, what's that stuff? GUI-based stuff. So I can pick either foundation or core foundation. I don't want core data and I don't want core services because these are not the project types that I'm working with. I can run an entire program in C or C++, however. But click on foundation down here or core foundation. A lot of people like to put it on core foundation as the default, because then you know it's just, you know, I'm gonna put it on foundation, but because I like foundation. I'm a minimalist. I don't want to put stuff in there I don't need. But if you pick foundation all the time, then you go, hey, wait a minute, that library's not working because it's part of core foundation, not foundation. Foundation is a stripped down version of it. For your project name, you can't use spaces, so go ahead and put something in here like I'm gonna put here test hello, or actually I'm gonna put here first program. First program. The organizational name is just going to give us our package information and our project type name. It's kind of like a property for our name. Don't necessarily need to put anything in there, but if you leave it blank, you're going to have a problem. So go ahead and put something in there. Are you doing attendance? Okay, so let me pause my video. Okay, we're back. Or maybe I should turn this on so we're really back. Now we're back. Can you hear me now? Okay, that's good. Okay, now we're back. And last I left, we were going over Hello World with the Xcode. And I'll show you Hello World for the iOS as well as the OS. So we can look at OS X as well. All right, so we chose foundation. We put in a project name, and we have an organizational name and company identifier, which is kind of like a path, but it doesn't really matter what you put in here. Actually, the only thing you really have to be particular about is the name of the project. So if I click on next, I pick a location to save it. I'm going to save it on my desktop. I'm going to press create here. In the old days, we had options for automatic reference counting. We had a bunch of other stuff in there. Don't have to worry about that anymore. The project creation is definitely simplified in this latest version. If you're working with an older version of the of the Xcode, go ahead and select the button that says automatic reference counting. Deselect the test cases, deselect the create Git repository. You don't need it. So just make sure you just only select ARC if you have that option. If you're looking at my screen, you don't have that option anymore. So if I press create, I get the project. and the project shows up. If I click on the top here where it says my main project folder, in the center, and this is your Xcode tour, I see the information that I typed in on that entry point, on that entry screen. So I see product name, I see the identifier, I see all this information. So you can change it after you create the project, no problem. You also see some other tabs here, and this is working with the iOS 7 and the newest version of everything. So the interface is a little bit different. Before we had tabs, now we just have links. I'm not really quite sure if I like the new styling, actually. It's more plain than it ever used to be. But these are the tabs. We can tab in between different project settings. If I come over here to the folder, I see inside the folder I have main.m, and I have something that looks very similar to what I just showed you out in DOS. Or, excuse me, out at the command prompt. So now what I can do is actually compile this and run this right inside of Xcode. So what I do is just click on this little button up here. So anywhere in the project, doesn't really matter where you're clicking, click on this little arrow that's in the upper left-hand side, and it'll say build successful, and then on the bottom of the screen I see hello world. So because this program is printing out hello world, I see hello world. And then I see that the program ended with the exit code 0. It's kind of like return 0, you know. So that's where that's coming from, actually. So now I see that how to run things from a command line perspective inside of Xcode. We haven't really written any code yet, but we're just basically getting familiar with the development environment. So now I'm going to actually close this project, and I take a look at the project folder that I see out on my desktop where I saved it. If I open it up, I see I have a project file, and then I have a folder, and inside of the folder I have those 3 files. So it's very similar to like Eclipse and other IDEs where your files are organized in in a folder, actually. So if I clicked on main, I get the main program again. So I can actually compile this if I wanted to from a command prompt, or I could not. I could just leave it alone if I wanted to and use it back. If I want to go back into this project, I click on this one here, this first program.xcode.prog for project. I double click on it and I'm back into the project. So I can essentially find and load projects that I've done before. So let's do an iOS application so you can sort of see what that looks like as well. Here we just have main. We don't really have very much in here. Under the frameworks, we have foundation.framework. This is the library that we're including, actually. Along with our headers, and we can see we have foundation.h, and we have all of the other headers that are involved. In terms of the framework, that's going to give us all of our standard libraries. So now I'm going to close Xcode, close the project, come back in again and create an iOS application to show you how easy that is. We're going to primarily work with iOS applications for this course, past the first couple of lectures, because then it gets more interesting. So I'm going to create a new Xcode project this time, and now I'm going to click on the iOS application above here, and I'm going to click on Single View Application. The single view is just going to be the generic type we're going to use today. We have different project types, but we don't need to get into that yet. So go ahead and click on Next. Now you see you have a couple more, but it's really just the same options over again. So now I'm going to type in test hello as my project name. Under the organization, you see it's actually, once you put it in once, it stays every time you create a new project. So it's actually kind of nice that way. Anyway, so now we have the company identifier, we have the company name, and we have this class prefix. Just leave it alone. I never put it in there. But if you wanted to organize your class files that are created in your objects to keep better track of them between multiple projects, you put a prefix on there. Don't worry about the prefix. On the bottom under devices, you see we've got iPad, iPhone, and Universal. I'm going to put it on Universal because I want to show you both right now. And if you put it on Universal and we click on Next, and I'm going to save it to the desktop, same as before. And then on the bottom is the same option as before, so I'm not going to create a Git repository. If you're on the older system, select ARC, and unselect test cases and unselect the get library because you don't need that either. So go ahead and press on create. And now you see I have same thing as before, you know, kind of the same thing, but I have a few more options when it comes to the project folder. And then now over here I see I have more of a .h.m kind of thing going on because I have an object, and what you're looking at is actually what's called a model view controller template. So model view controller, MVC, is the object-oriented design pattern that's used to build object-oriented programs. So it's true for Java, true for Smalltalk, Objective-C. C++, you can loosely follow it as well. Where this is the model, or you're going to call it the data model, which is the app delegate. App delegate is like the controlling data, controlling traffic officer for the program. I don't know. Then we have the view controller, which controls the view, and then we have the view. In iOS, they call it a storyboard. So the storyboard, I just clicked on the iPhone storyboard, and it looks like an iPhone here. So if I click on the storyboard here, and I kind of say I have this little window here, I can make the window smaller. I can make it bigger with the controls on the bottom of the screen. I can actually move this around as well. On the right-hand side, I'm going to show you the panes right now. I have a couple of different things. I have different panels, and you see I have these little things up here. And these are clickable buttons. And I have 3 panes to the entire system. I have the left pane, which is the guy over here. So if I click on it and it turns to blue, it's hard to see it, but up here this color is changing from black to blue. It means it's open. If it's black, it's not turned on. And you can see what I'm doing here is I'm moving over the left-hand pane. And then we have the bottom one. That's where the command output came to. And then we have the left one. It shows up on the right-hand side of the screen, I should say, not left. This one has subcomponents to it as well. So this guy over here doesn't have any subcomponents. This one doesn't have any subcomponents, but this one does. This one's got this stuff up here. What's this stuff? It's different property screens. So there's a lot of features in here, but they're all spread out and they're all organized by what they're supposed to be used for. This is the window. So in the window, I can change it. I can change the view itself. I can change, let's say, the background color, make the background color green if I wanted to. I can drag and drop items. As an example, this is what's called the library. So this is actually what they used to call an XIB, or XCode interface builder. And then it changed names and it turned into a storyboard, which is kind of interesting. So if I type in label as an example, what I'm doing is building hello world here. If I type in a label and I put a label out here on my canvas, I just drag it out. So if you want to do this, click on the background. Make sure that this tab is selected. And then we're playing with the properties. So we got like this property. Well, we have this window, this window, this window. We want this window open here. This is called the attribute inspector. And then in the attribute inspector, we have subtabs here. So we could put objects in. We could put, we can search for objects. You see I have a label showing up in the window because on the bottom of the window, which is kind of hard to see, I have the little itsy bitsy little search area. So I can drag, and here's like, let's put a segment controller on here. So I got a segment controller that I put on here. And I got a label that I put on here. So on my label, I can double click on it and actually type in hello world. Hello world, there we go. And if I don't like the font size, I can come over here. After clicking on the label, I can change the properties of the label over here. So I'm going to make the, well, let's make it plain text. I'm going to make the text in red. And I'm going to make the text bigger. So I'm going to raise the font to like 27. Sounds pretty good. Make a big label here. So I got hello world out here. Let's make hello world a little smaller. There we go. I got hello world. I got this little kind of toggle thing going on here. And I can change other attributes about this. You'll see this as we go through the course. Over here, I can click on the first and the second, and I can see that the title here that's put in here, I can call this something else. I can say options or something. And now I said this option here got changed to options instead of second and first. So I can click. Let's call this segment here. Segment number 0 is going to be a 1. And then I can toggle to segment 2 and call this one 2. 2, TWO. There we go. And then I can say, oh, I thought I changed this one. Let's see. Change this one to 1. So now it says 1, 2 on it. So I'm changing the properties. I'm not showing you this object yet, but I'm changing the properties of the object through the GUI interface instead of having to do it programmatically. I can also do it programmatically where I set the options and program it, that way. So let's see what we got here. We have a text field. I can put a text field out here as an example. And the text field allows me to type in text. And I can put a button down here. Let's put a button down here too. A button. And we want to do let's see, how about a round? Yeah, we don't have the round anymore. Let's just put a button. So I put a button out here. And I'm going to type in here, click here. And here, I'll make the button a little bit bigger in text. Let's just make it like, I don't know, 23. That looks pretty good. And there we go. And then, we can change the font, the text color. We could put the text color in red if we wanted to. So you can kind of see how the GUI development is done. Yes?
We kind of got lost. We're not able to see those button text options.
Perfect. So you're not able to see this over here? So look on the right-hand side of the screen. You have a little toggle.
Yeah.
Are you pressing on the toggle?
Yeah.
Perfect. Click on the background. When you click on the background, you should see on the bottom of the screen the library options. Now this is, I'm only seeing button in here because I typed in round something down here. Make sure you don't have anything typed in on this filter bar and you'll see more stuff. Do you see that? If you scroll down, actually it's right here. Do you see this? If you don't see these options, make sure you're clicking on this guy right here. He's the second to the right on your screen. There's kind of small little buttons, but they're changing the view.
Yeah.
If you click on that one, then you should be able to drag stuff over to the canvas. So what I highly advise brand new people doing is drag a bunch of stuff over here, play around with it. Because first of all, you learn what the components are, and then you learn by trial and error how to change the settings on the components. I'm just sort of building a bunch of stuff here. So let's say for example, I want to put an image out here. I can go out to the internet. Let's just do that real quick, actually, because I think I have an internet access. And I'm going to type in here, what do I want? Oh, let's go button.png or something. And go, oh, here's some cool buttons. And so I'm going to click on this one here. I'm going to download this one. I'm going to save the image as a forward-button.png. I'm saving it. I just pulled this image out of a simple web search I just did a few minutes ago. And I got this image and I just saved it. And then now what I can do, and I'm going to minimize the screen a little bit, I'm going to say, well, I want to use this image and I want to put it on my button. So I'm going to take the image and I'm going to drag it into the project. So I saved it on my desktop. I'm dragging the image inside. And I'm going to copy the item into the destination folder instead of linking it. If I don't, I'm going to link it. And then if I remove it from the desktop, I'm going to lose it. So instead, I'm going to copy it in. And then add to targets. Just leave the defaults. The target's going to be test hello. Actually, I'm going to add it to that. And then I'm going to click on finish. And then now I see I have a button in here. So what I'm doing, don't worry if you're not following this yet. I'm just showing you features of XCode. We're going to build a project from scratch where we'll do it. But did you have a question?
No,
Okay.
I just wanted to follow that again.
Oh, okay, if you want to see what I just did, what I did is I was showing you how to bring items into XCode. So you can go to a web browser as an example. I actually just typed in button space .png and I found this first thing that came up when I clicked on this guy, and I just right mouse clicked and I did a save as. Saved it to my desktop. And then I said, I don't really want that in my project. So all I did was click on it from the desktop and drag it into the project. And I added it to the project. Now, if you did this with Eclipse, you'd have to put it in a certain folder, resource folder, and you have all that Java automated stuff that goes on, and it's a little bit more complicated. What I'm trying to demo to you is how easy this is compared to that. Anyway, I'm going to go back to my iPhone storyboard where I was before. Now I have this new resource I put into the folder. It's called /button.png. All right, so what I'm going to do with that then is load this into this button here. So I'm going to click on the button because I want to change the button properties, and I'm going to come up over here to the right-hand side of the screen. And you see where it says image. Let me make this a little bit bigger so you see what I'm looking at. Button image, default image. If I open it up, I see /button.png is one of my options. So I can select that. Now I see /button here that got loaded into my button. Now it's on an image. So I can come up here and I can remove the click here text that I put on there. Because you can't see the text anyway, the button's going to cover it up. And then I can click on the sucker here, and I can actually change the dimensions in the properties window. But I don't really want to change the dimensions. Instead, I just want to do it this way. So you can change stuff in the properties window, or you can do it graphically just by clicking on it. And then you can see over here it says width, height. So if I want to measure, I'll go 98 by 98. Let's do that. Oh, there we go. Now I have a button here. It says 98 by 98. So when I click the button, well, you'll see it actually, you're not going to really click it. If this were an iPhone app, you'd be pressing it with your finger. Well, this is an iPhone app. So now what I can do is kind of say, well, okay, well, this is a nice little GUI. How can I see this thing work? Fortunately for you, this is iOS, not Android, so we don't have to download a bunch of emulators and stuff like that. Instead, we can use it just by pressing the little button over here. If you press the little arrow that's on the left-hand side, you see it says it's built successfully. And then in the background, it's going to bring this thing up. This thing here is an iPhone Retina 3.5 inch. And then I see, oh, look, there's my application. So I can go, oh, look, there's a button. Press on the button. Oh, look, I can type in here, and a little keyboard comes up. And I can press the keyboard, or I can just type something in here. And then I can go, oh, look, I can select these guys too. So it kind of shows you what the interface looks like. This is called the emulator. It's an iOS simulator. I can actually close the simulator. Actually, I can exit out of the app that's in the simulator. Well, I used to be able to. I can reset the contents of the simulator so that the simulator is now empty. Not going to show me anything. It's basically, here it is. So now I have it's an emulator / simulator. Actually, I should have internet access on here. I should be able to, yeah, look, I have internet access on here. It's an emulator. If you're in the Android class, you probably noticed how fast this loaded up. Very fast, very nice. That's why I say this kind of development compared to Android is like the piece of cake. It's so much better. All right, so now let's say, for example, we want to stop it. This is what this box here, we can stop the emulator. In XCode, we can actually monitor, see what's going on with the project. And now you're looking over here and you're going, well, my stuff's gone. Where did my source code go? So I can actually click on these little buttons here to change the perspective. So this was in run mode a few minutes ago. It was in debug mode, and I was seeing a bunch of, there's no debugging session because I just ended it, right? So now I can click on this little folder thing over here and get my folder back. Or I can click on here and see, well, what is the hierarchy? And see a flattened version of it or a hierarchical version of it. Search for something. What are my error messages? What are my test cases? But we didn't do any test cases in this case. So I'm going to go ahead and click on the envelope that's over in the left-hand side over here. And if I click on that, I'm going to see, well, I've got two storyboards. I got a storyboard for the iPhone, and I got a storyboard for the iPad. So I'm going to click on the iPad one this time, and unfortunately the iPad's kind of big. I had to make my screen a little smaller. So I'm going to come over here and use this little arrow here, and I'm going to move it up a little bit. And so now what I'm going to do is drag some stuff onto the iPad. that I've got. And then I'm going to run my program as an iPad. So I'm just going to take a text box and slip it over here. Oh, I can't do it when it's minimized. Okay, we'll make it bigger. So now I'm going to put hello world on my iPad. So, whoops, I did a text field. That's right, we can just put a label now too. I'll put a label over here too. And my label is going to say hello world. Hello world on iPad. So now I have, I'm going to change the font a little bit, make it a little bit bigger so you can see it from a distance. That's pretty big. Actually, I'll just fill it up. There we go. I could put a bunch of GUI components on the iPad. Now I have an iPad interface, iPad view, and I also have an iPhone view. And I still only have one project, but I've got one app now that's going to work on both devices. So now I'm going to run it on the iPad. So over here, on the side over here, I've got iPhone, iPad, iPad Retina, all my different devices. I'm going to select iPad, and I'm going to click on the little arrow to run it. Now I should see the iPad interface come up on my app. And here it is. This is the one I put on my iPad. This one says Hello World on iPad. So I have one interface, one view for the iPhone, one view for the iPad. And then people are wondering, well, that's interesting. So I can build two applications in one. I can still run the iPhone on the iPad and run, you know, so it's like if you've ever downloaded apps from the App Store, if you have an iPhone and it says you're on an iPad, but it's an iPhone app. So let me show you something else that's really cool too. If you have a device, which I do, I have an iPad device, and you got a cable for the device, and you sign up for a developer's license, which you'll do if you want to get into this. I can actually run this on the device. So what a lot of people do, because in order to deploy it, you actually have to like put it on a device, but you can't put it in the App Store until it's ready to go. And you can't take it out of XCode until you're ready to put it into the store. There's no massive distribution of it. If I plug in my device, let me close my emulator here. Oops, I'm going to have iPhoto show up. Let's see, get rid of iPhoto. We don't need iPhoto. Bunch of pictures on there. So now I have oops, we're good. I have to unlock it. So I've unlocked my iPad, and my iPad wants to get upgraded. Okay, I'll do that at lunch. So now if I switch over to my options, I have one on the top that says Barbara Hecker's iPad. If I select Barbara Hecker's iPad, which is the iPad I just connected, I see it now as part of my options. So I don't have to run it on the simulator. I can run it on my device. If I'm going to run it on my device, then I just press run. And you can't see it, or maybe you can see it from a distance, but in a few minutes it's going to load up on this device over here. And it's going to be a really stupid program, actually. It says Hello World on it. It doesn't have very much to it. If I minimize it now, it's on here. So now I can actually stop it here. So XCode doesn't think it's still running. And I can go back and I can run this as much as I want. I've actually installed it on my device. So it's a little different than installing with Android. You have to have a developer's account to do that, or you have to have access to the student account. So for those people who have iOS devices who want to be able to do this, maybe this afternoon we can do this. We can go through the steps, or we can also do it in the second weekend or the third weekend. But it's kind of fun because now I can do stuff. I can carry around my iPad, and then I can say, hey, you want to see my cool app? You know, here it is. You know, and I can show people my app very easily. If I want to distribute it to other people, then I have to put it in the App Store. That's totally different. So you can't put it in the App Store with a student account, but you can put it on the device. Works with iPhone, iPad, anything. iTouch. You can do it on an iPad. You can do it on an iPod Touch if you have one of those as well. So it doesn't really require very much at all, actually. So I'm going to go, actually I'm going to leave it in because I want it to charge, because I have to do some updates on it, it looks like. But that's how the UI works from a UI perspective. And we're looking at Objective-C source code, so let's take a look at Objective-C. So if I don't want to work with iPad, actually I want to work with the iPhone. So I'm gonna switch this over in my emulator so make sure I can do this in the past and in the future here. I'm gonna click on the iPhone simulator and go back to this guy over here. And if you haven't done it already, drag a label, stick a label on the canvas. And put a text box. You don't need this guy here. I'll just put this guy on the bottom. What we're going to do is put something in the label, press a button, and, put something in the text field, press a button and have the label changed. That sounds pretty easy. Then we can take and explore Objective-C, which is what we're here for. So I can do this before lunch, and it works out just great. So I'm looking at the time right now, because we want to make sure we get our barbecue on time. So, and now we're going to play basketball. Very good. All right, so make sure you got a label and you got a text. So this one here, if you take this off of here, you click on the item, you see you got the properties over here. Make them beautiful. You don't have to put a label. You don't have to put an image on your button, just any kind of button. So you need those three components, a label, a text. So if I type here text, it's called text field. And then a button. Once you have that, or do people need a minute for this? Because some people did this already. Assuming you have that, I'm going to get rid of the side panel because I don't need it anymore. And you can move this over a little bit. I like to move it over because I like to see everything all at the same time. So I'm not having good luck here moving this thing, but anyway, we'll just leave it alone. There's this little guy in the middle. So this is changing the way that this perspective in the middle is going to look. So this hides and shows different panels. This gives you different components. The thing that looks like a tuxedo is a source code editor. So I call it a tuxedo because it looks like a tuxedo. Actually, now it looks like a happy face. In the old days, it looks like a bow tie and some buttons. It looks like a tuxedo. In fact, if you pop your mouse over, you'll see some fancy labels. This one says, show the assistant editor or something. Maybe he's supposed to be like a butler. This is the assistant editor. You know, like maybe it's like the concierge. Or I don't know. He's assistant. So, anyway, and I'm not gonna go for that one. But if you click over here, you see this file is called viewcontroller.m. And you go, oh, that's great. And up here you see the name of the file is called viewcontroller.m. If you click up here in the very small menu bar on the top of the screen, you see you can switch between viewcontroller.h and viewcontroller.m. So here's where things get kind of interesting, and this is what we're here for, to learn Objective-C. So in the .h file, we see this @ interface. And the interface that we're seeing is called viewcontroller, because over here we have two sets of files. And if I click on the file over here, it shows up over here. So if I wanted to, I can just click over here and just get one pane. Here I get two panes. This one I get a different pane. I never used this one, actually. Let's not use that one. Let's go back over to here. If I wanted to see both of them at the same time, I can click on this guy. Gives me my first pane. Click on my editor, and I get my second. Sometimes you're gonna want to see both at the same time. We want to see both at the same time right now, because we're going to drag and drop and we'll see how this stuff goes together. But to show you what we're looking at, we're really editing these two files over here, viewcontroller.h and viewcontroller.m. Viewcontroller.h is the interface file. The M is the implementation file. So just like C++ has got a .h and a .c++, same kind of file format. So what do I got going on here? Let's just take a look at however you have it figured out. I want to go into the .h. So open up either by clicking over here the .h or clicking it using the tuxedo. What we're looking at then is the structure. We have an @ interface and then we have an @ end. It's kind of like the beginning and then the end. It's everything we stick in between becomes our interface. In C++, I'm trying to remember my syntax here. In C++, when we create a class object, we have to use class space view controller. That was the name of my class. And then if I had inheritance going on, I'd put a colon in there, and then I'd say like public some other object, you know, person or something like that. And then I'd have like an opening and a closing bracket, and everything would go in between. And if I was doing this in Java, I'm going to write this in 3 different languages here so you can see the difference. The syntax is, it's the same meaning, different syntax. In Java, and then everything would go in here, all my data and all my properties and everything. By writing this in Java, we don't have this, we have extend now. Extends, and then we take out the public because we put that inside of the file, and now we got this going on. Very similar. Or actually, we could even do this here. If this were Java, we'd do this here. Public class view controller extends person. And then if we had, you know, some interfaces would be, you know, implements this interface, that interface. So in Objective-C, we get add interface, add end. So that's like one of the hardest things to get familiar with. But it follows a C++ inheritance. So it's view controller is the name of the object that we're creating, but we're not calling it a class. Instead, we're calling it an interface. And then the colon is going to say, well, it's coming from, it's inherited from view controller. And view controller is this concept that controls these storyboards that we just looked at a few minutes ago. So inside of here, I can still put the opening and the closing brackets if I want to. And I can still define some variable as an example like integer I, and float f, and all this stuff that I'm familiar with C. I can still write C code in here actually. I can define variables and stuff. The funny thing is though, the variables, they go inside of here. And then your function prototype, your method prototypes go elsewhere. And then the method prototype syntax is a bit odd. I mean, it's different format. So you start out with a plus or you start out with a minus sign. The minus sign says it's an instance method. The plus says it's a class method. I'm going to go through a lot more of this when we get out of lunch, but I'm just going to orient you to the syntax. And then we start out immediately with a data type, but instead of saying like the data type, we put it inside of opening and closing brackets like that. And then we give the function a name, you know, like do something. And then we can put other stuff at the end of it, little like parameters and stuff. And we can do all sorts of different things with it. And we put a semicolon at the end to say, well, this is a function prototype. So we're not writing the function, we're just putting a prototype in it. Prototype is just the front line normally of the function to say, hey, we got this function. This is what the function looks like. This is the syntax, unfortunately. People look at that and they go, well, that's nothing like C++. If I were writing this function in C++, I'd start out like this. I'd go void do something. Do something. And then I'd have like something like that. That's the equivalent in C++. If we're doing it in Java, we don't have a function prototype. We just have the implementation. Yeah?
So in the header files, we basically just declare all the functions, and
Yep.
then in the .m file, we actually do the
Implementation. Same thing as C++. Different syntax. So the syntax is the same as C++. Well, syntax is different, the concept's the same. So in your header file, which is where we're in right now, I'm creating I just created, and you notice that here I didn't get any error messages. Because remember what I said before about C and C++? You can write that in Objective-C, you're not going to get an error message. However you want to, if you're going to write Objective-C, write Objective-C. So I'm going to take this guy out. So in my .m file, if I switch over to the .m file, I can implement do something. And then in the .m file, I'm going to hover my mouse over here, this little, it's a warning sign. If I hover my mouse and I click on the little warning sign, it says you have a method definition for do something that's not found. And I'm like, yeah, I haven't implemented it yet. I just got here. So then now we can see the method here. And the method we have here is you know, view did load, and we don't know where did that come from, and did receive memory warning. And this has to do with the life cycle of the app, and I'm gonna look at that after lunch. But for your orientation right now, I'm just gonna implement that method. And so the line that declared the method is the line we're gonna implement it, very similar to C++. So if we come back over to the .h, I'm just gonna take a shortcut here. I'm gonna copy this line here, and I'm gonna go to the .m. and paste it in right under here, not worrying about the rest of the stuff in here right now. And then provide some opening and closing brackets. And now I have a method implementation. And in the method implementation, let's say I wanted to write something to the screen. And I wanted to do like a printf or something. Then I can just put that line of code in. So you're writing the code that's going to implement the do something, whatever that happens to be. So we have this thing called nslog. Nslog works everywhere. All the syntax we do works everywhere. So we could do like, nslog. And if I start typing stuff in, I get, oh, here's nslog. What format do I want? And then I can put the format of the string in there. And if I just put a string in here like, I'm here, I'm going to get a message here that's going to tell me that it doesn't know about I'm here, because I haven't really made that into a string. So I can put that little @ symbol over here and get rid of that message, and says I'm here. Now if I run the app, I'm going to have an nslog actually, which is actually kind of interesting. So a lot of people do error checking this way. So if I put it back on the iPhone Retina, and if I run it, I should be able to check my nslog and see that. But the funny thing is I didn't put it anywhere, so I don't have, my nslog would actually show up down here. But nothing's going to show up down here because there's nothing attached to that functionality. There's nothing controlling when this method is going to happen. We don't know when that method is going to happen. So if, let's say, for example, we wanted to use the event-driven behavior of the button press. So I'm going to close the simulator, and basically you don't even have to open it. Just nothing's going to happen. You're going to get the same as before. I just created a method, but I didn't do anything with it. So I'm going to click on my storyboard, and this is kind of the interesting part. So this is very much event-driven behavior. So I'm going to create an event. You're going to be wondering, well, how are you going to create the event? Well, I have to wire the component to the .h file so that the controller knows about the component, which I'm waiting into the future for it to automatically be wired. Let's see what happens with that. So I'm going to take this button here, which is going to give me an event. I'm going to click the button. Something's going to happen when I click the button. So if you click on your button to select it, and then now you figure out why I have a mouse connected to my computer. I find it easier to use an external mouse than it is to use the touchpad, because now you're going to really figure out your touchpad skills. And my touchpad skills aren't that good. So if you right mouse click, you get the little menu that shows up. So try right mouse clicking with the touch thing. I've always found that awkward. I don't like the touch thing. That's why I have this mouse plugged in. So we have these events that occur with the button. And the event that I'm going to look at is going to be called the touchdown event. And the touchdown event is going to run that method that I gave it. So this is what I call wiring. And actually a lot of other people call it wiring too. I'm going to wire the components. So if I right mouse click, I get the button window come up. I'm going to go down here where it says touchdown. I'm going to click on the little plus here. And you see I got this little blue line that's starting to go on here. In the old days you had to press down the control key on the keyboard. Now you don't have to. If you have an older version of XCode and you're doing this, you have to press the control key on your keyboard while dragging. It's called a control drag. You don't have to do it, you can just drag it now. Why they had you press the control button, I don't know. So this is a lot easier. Where do I want to stick the sucker? You see I can't stick it anywhere wrong. Make sure you're doing this. So most people go, how did I get here? Click on the storyboard, click on the tuxedo. So you have, and then make sure you switch over to the .h file. We want to make a function prototype for this button event. If I click on the touchdown or any, just pick any of them actually. I can't put it in the wrong spot. This is the best part. In the old days you could put it in the wrong spot. Now you can't put it in the wrong spot. You can only put it here. It wants to be between the at and the end after this opening and closing brackets. I'll talk about that later. I'm going to put it right here. So if I let go of the mouse, I get a little automated screen that comes up that allows me to identify what this is. I'm going to call this a button press. Button press is going to be of the type ID. ID is a generic data type. I'll talk about that after lunch. Instead, I'm going to switch the type. I'm going to put the type into a UI button. Why? Because I want to show you how the data type shows up in the method that we're going to create. And then the event is touchdown, so if I decide I don't like these guys here, I didn't pick the right one, I can switch it right here. Why do they put this here? They should just have a wire button. Maybe they'll have that in the future, and then you pick it from here if you wanted to. Argument sender. Well, I'll talk about that later, probably not until the second weekend, maybe not till tomorrow. But the sender is the UI that's sending the event. It's event-driven behavior. We'll just take that at face value right now. If you press on connect, you see I have another method prototype. Now I can close the little button, close the little box if I want to. Now I have another message prototype. Looks like my other method that I created, except for this one has like a little plus next to it. And if I put my mouse over it, it says button, and it's showing me which component it's connected to. So when I touch down on that button, this method's going to fire. This function's going to move. So that's how we do our event-driven behavior. So we're going to have to write some Objective-C code to make that actually work. So what do we have in here? This is a parameter. I did not put any parameters in the do something method because, because. So instead, I'll show you parameters after lunch. But this is the name is called button press. The data type is an IB action. So the IB action is IB stands for interface builder. That's this interface. And the action is going to be the touchdown event that's going to occur when I press the button. Just take that at face value right now. If I switch over to the .m file, now I have the implementation for this, but it's already filled in for me. So one of the best things you get with dragging and dropping and creating it, going from the interface to the implementation, to the .h and to the .m, is it does it for you automatically. You can go the opposite way around. You could put the do something event in here, drag do something over to the button, and have that event associated with the button, or have that associated with something else. So it works both ways, but it's helpful if you start with the interface builder and you go to the source code file. A little easier that way. So on the button press, if I wanted to, I can do this. I can take and put this line of code in here. Haven't really talked about the syntax of Objective-C yet, but that's kind of like a method call that we're familiar with C. So now if I press the button, my NSLog should show I'm here, I'm here, I'm here. So if I run it, I should see that in the bottom of my screen. Still not having anything with the GUI. So nothing's really happening with the GUI. But you see, whoops, you can see it back here. Let's get rid of this little screen here so we see it full screen. Every time I press the button, I'm here, I'm here, I'm here, I'm here, I'm here, I'm here. Great, that's the NSLog. So we can see that our button functionality is working. And we can see this, but we want it to show up out here. So then we're going to have to write some Objective-C code about past NSLog to have some activity occur. So I'm going to close the simulator a little bit. You can actually leave the simulator running if you wanted to. And I'm going to get rid of the bottom window and come back to my code and say, all right, let's have something let's just have something more exciting happen here. Let's change the label. So in order to change the label, we have to make a local reference of the label. So just like we created this method, this IB action that was associated with the button, we have to create the existence of the label in the code. So if we switch back to the .h file, I can come over here. So I have viewController.h. ViewController is the controller that's controlling my view. My view is nothing more than just the GUI components. I'm going to click on the label, and then I'm going to try and drag, and I'm going to go, well, it doesn't work. I'm not getting anything. I put the label over here. So unfortunately, with the label, you have to press down the control button. They took it away for the buttons, but it's still the case on the label, which is just ridiculous. So you press down the control button, and you click on the label, and then you start dragging the label, then you get the arrow. And again, the nice thing is that you still can't put it in the wrong spot. You can only put it in the spots where it lets you put it. So if I drop it right here, let go of it, let go of it. You have to actually hold down the control button when you drag it. What you're looking for is that blue line to wire it. And then I'm going to call it the label. And then the type is already a UI label. We're going to get into the strong versus weak in a few minutes, but we have strong, leave it on weak. It means when is it going to be released? It's weak, means it's going to be available to be garbage collected. If it's strong, it stays around for the entire life of the program, never goes away when we're not using it. We switch screens to another screen, it's still there. So now I get this little bit of code that got added to my program, and in my added code here, I got this little thing here. And I can click on it here, and I have this thing called a property that was created. So we have property, and then we have synthesize that goes along with it. You're going to wonder, oh, this is like overkill. You know, it actually is overkill for Hello World. But if I wanted to, I can come up here and say, well, I just want a UI label. So I use UI label as the data type. I'm just going to call this my label. And I go, well, that's a better, you know, that's good, but I'm going to have to make this one then a pointer if I'm going to do it this way. So then I have to use a pointer. So we can use pointers, or we could not use pointers. We can declare local data members, or we can use property and synthesize, which come in a set. So let me talk about both of them right now. So I'm creating a data element, just like integer I, float f. This one's called a UI label, my label. I'm going to use them both, actually, in this program. So at property, at directive, it says create a property. Property is weak, non-atomic, don't worry about that. It's an IB outlet, which we have input, we have output. Action. So we have an outlet is like a text box, like a label, where it's where we can put output. Outlet, if you want to think of it that way. Action, action. Click on it, drag on it, double click on it, touch it, do something with it, it's an action. Really only two categories, so you're going to have an IB label here. And if you look at the syntax of what it did for you, this did the same thing as this. This is a member of the object. This is a property of the object. They're both pretty much doing the same thing. This is going to create some setters and getters for us. If you're familiar with setters and getters, we're going to hit that after lunch. But this is not doing any setters and getters. This is the C style, or the C++ style of doing things. This is the Objective-C style of doing things. If I have an at property over here, I simply do this. I move over to the .m file. And I add in here, under my at implementation, I like to do it at the top because then I can find it easily. I can do an at synthesize, and if I do that, I'm going to put the name of the property in there. What I did with that is I saved myself a bunch of mouse clicks. If you're in the Java class, remember when we created the Java objects, and we did setters and getters and constructors and all that other stuff. Forget all that. The at property and the at synthesize allows me to do setters and getters automatically. It just makes it part of the object, makes it a property of the object. Synthesize allocates it, initializes it, and gives you all the methods. So now I can, get the label, set the label, populate the label with something, use the label. Take that at face value. I have a lot more information to give you on that after lunch. And what I'm trying to do is expose you to the environment. Actually, in a few minutes, you'll see the entire thing, all the pieces put together. But all right, so now if I have this here, then I can write some Objective-C code. And the Objective-C code is when I hit, let's wire the text box too. We'll make this a little bit more functional. So go ahead and go back to the viewcontroller.h file if you're there. Don't worry if you haven't been following along with any of this stuff, because we're going to do this a lot slower and more of a tutorial fashion after lunch. This is your introduction. I'm going to label the, I'm going to property the text just the same way as I did the label. What I want here is when the user types in something here, I'm going to change the label with whatever they typed in. So I can take the label, and I can also make a property out of that as well. So I'm going to control drag the label over here. And I'm going to call this one the label. Oh, excuse me, this is the text. The text. And so it's a text field. I'm sorry, I called it a label. It's a text field. Press OK. Now I have a text field over here. and I called it the text. So I'm going to switch over to the .m file, and I'm just going to put a comma in here and say the text as well. So I can synthesize them both in one line. I can actually property them all in one line as well if I wanted to. So I can do it this way with UI label. I can also do at property and then just start typing in my own properties if I wanted to without dragging them over. So this is traditionally the way that we're going to do UI components. Now, because I've wired over, and if I switch over to the .m file, I can see now I've wired and I synthesized the property and the text. When I press the button, I can take the text, get the text, and then set the text of the label with whatever I got. Well, the text that I'm going to get is going to be a string or something. Or maybe I can just manually set it. So I'm looking at the time and I'm thinking, well, let me wrap this up so we can start with I have a more formal version of this we'll do after lunch. But just to wrap up your introduction here, on the button press, we'll leave the log alone. Just leave the log in there. So instead, let's just set the text of the label. How's that sound? So if I were in C++, if I had a label, and this was the label, and I can say, the label, right? And I use a dot notation, and I can say, well, how about text? And that one's going to be equal to, well, we know we have to put this little @ symbol here because we're defining a string. I'm going to call this other text. And I've written a legal line of code. And the legal line of code I've written is C++ fashion. So I can also write this another way. So I'm going to comment out this line of code because this is really, kind of like a set text, get text with a dot notation. Objective-C doesn't actually use the dot notation. Instead, it uses a different format for method calls. To run a set text, which is really just text, I use these brackets here. So you'll see opening and closing brackets everywhere. You put the object that you want to send the message to, which is going to be the label. You put a little space in here, and you say, well, what do I want to set? I want to set the text. And you use a colon to indicate the parameters. I'm going to write this method one more time for you so you can see it differently. But parameter, what's the parameter going to be? It's going to be at quotation mark more text. Let's just call it more text this time. Whoops, and if I spelled label correctly, I'd actually have a piece of runnable code. Let's see, the label, and let's go over here and we'll say, what is this? It does the UI label declares text. Well, let's type in here set text. How's that? Set text. All right. You can see the sort of the error checking that happens. Didn't know text. So this is a way in C++ actually to set a property on a component. It also works in Objective-C. This is Objective-C code. If I wrote this code in C++, which is not setting a property, but it's running a set text, get text, it'd look like this. It would be the label, which is the object, dot set text with text. And it would look like that. Because C++ uses a dot notation and a method name, and then we send it a parameter. So Objective-C uses opening and closing brackets that look like that. And then we have the object, then we have the message that we're sending to the object. And the message that we're sending is going to be set text, and we have this @ directive because we have to tell the compiler this is going to be a string that we're going to send it. And we're going to send it more text. So I'm going to get rid of the, let me comment out actually. You notice the comments are the same. So the two lines give me my comments. So a lot of your C++, a lot of your C is going to translate very nicely. The method call, a little bit different if you haven't noticed. The method call is using this syntax. After lunch, what we're going to do is go over the syntax. What I'm doing right now is kind of orienting you to the programming style and the whole methodology that you're using in terms of model view controller and XCode. So right now, if I press on the button, the label, the text is going to be changed to more text. I'm still going to have my NSLog occur, but let's just press the button here. So I'm going to run it, and I'm going to press on the button, if I have this right here, the retina is running here, and I press on the button, I get more text. So now you see more text. So now I have a few more minutes here. I can change this here a little bit and say, well, I want to do a, are you sure to close the project? No, let's just cancel. I just don't want to close the project. Hold on one second. I want to close the emulator. I like closing the emulator because it brings it up fresh and loads up the project fresh. You can leave it in the background if you want. So now I can use regular old C code. And where am I going to find the C code? Well, I'm just going to write my C code. So I'm going to take all the stuff I know about programming in Java and C++ I'm going to use right now. I'm going to put, if, well, didn't I do an integer over here? I think I did, actually. The .h file's got integer I in here. I'm like, okay, let's just do I. So I'm going to say if I is equal to 0, then, or, I'm going to have opening and closing brackets. I have, like, what code am I writing here? Like, I think I was writing Visual Basic for a second. So, if I is equal to 0, then set the text to more text. And then let's say I is now going to be equal to 1. That's good. And then let's put an else in here. This is C++, or C code, actually. Else, let's just do this here. Copy it, stick it in here, paste it. And we're going to go, well, if then I is going to be equal to 0, and then we're going to say my text, my other text. How's that? We'll just change the text around a little bit. And then now I can say, well, that I'm going to change my counter. The beautiful thing that we have with Objective-C is we have automatic variable initialization. If I wanted to, I could initialize it, and if I was going to initialize it, I'd put it up in the view did load. So in C++, we have main. Main starts. Main is like the starting point. We stick everything inside a main. In Objective-C and in iOS development, we have this view. Did it load? If it didn't load, you don't have a program running. If the view did load, it's kind of like main. Everything's going to start there. So if I wanted to in main, view did load. I'm going to talk about super and this and self and all that other stuff later. But I could just say integer I is equal to 0. I can set I to equal to 0, or I can remember that I is going to initialize automatically, and I'm never going to get a message like C++. Because C++ is statically allocated, statically defined, strongly typed as well, and Objective-C is strongly typed as well. But it has like a looser running system. If you set integer I, we're going to initialize integer I to 0. Yeah?
So you don't have to ever declare the data types for whatever variables you're creating?
You don't actually if you use ID. ID is a generic data type, kind of like a pointer.
So then whenever you set the value, it will automatically
be whatever default value. So if I set a data type, it is strongly typed language. You actually have to declare a data type. But we have a loose data type called ID that I'm going to get into after lunch. ID is generic. ID says it's anything you want it to be. It's just a pointer.
Like the JavaScript var?
Yep, just like that. So a lot of the programming language concepts you might be familiar with kind of relate over, but they're implemented differently. Because I put I in .h, I know about I in the .m, it's part of my object, and my implementation on my view did load, I'm going to set I to equal to 0. So when I load this up, I is supposed to be equal to 0. If I took the I is equal to 0 out, it wouldn't matter because I's are going to be implemented already to be equal to 0, because when I declared the variable, it automatically got initialized, which is what you don't get in C++. You'll get, you're using a variable without initializing it, or without, declaration without initialization, or no assignment, or something like that's going to come out of it.
But if you use it without declaring it here, doesn't it have like a null value or something that is assigned?
No, it's got a default value. If it's an object, it's null. If it's an integer, it's 0. If it's a float, it's 0.0. If it's a string, it's an empty string. If that's a character, it's an empty character. So it has like a default initialization to it. But just to be on the safe side, it's nice to be able to declare it to some starting value. If you're going to do that, the view did load is sort of like the main method. But nothing else is in there. It's just the view, because the view is going to load, and then your activities are going to happen after that. So it's all broken out into different subsections. So now I just put some regular old C++ or C code in here. Now when I run it, I'm going to see, oops, I set this to 0 to 1. Okay, good. Now if I click on my little button, I can say it says more text, my other text, more text, my other text, more text, my other text. Now I can like do stuff. I'm just changing a label. I'm not doing very much right now. If I had put some stuff in here, then I can use that if I wanted to. And then I can add that to a string as an example. So if I did this and I said, well, okay, let's close this for a second here. I can look at and say, well, okay, what do I have over here? I have this text box. It's property. Well, what if I wanted an action on this? So I made a property out of this text box. And I kind of did that on purpose to show you I can make a property out. I can make a property out of the button too. I'd want to make a property out of it if I wanted to change the label on the button or do something about the button. If I want to get the action that's associated with the text field, then I got to wire the action. I do that, and this is kind of advanced right now, but if I right mouse click on it, I can see I have this did end on exit event that happens after I type in something and I press return, I ended. And then I've exited. And as soon as focus leaves that text box and I hit the button, I've exited. So I did end, I've exited. Now I'm in another location of the program. I'm going to drag the icon here that says did end on exit. I'm going to put it over here. And I'm going to put in here text stuff. Call it text stuff. I like to change the ID over to what it really is, and it's a UI text field. It says did end on exit. So I press connect. Now I have a method over here. It says text stuff, and it's an IB action. So if I go over to the .m file, I see now I have on the bottom I have text stuff, an IB action. So now I can get the text. And I can get the text from it, and then I can do stuff with it. So what I'm going to do, because I'm looking at the clock and I don't want to miss out on the barbecue, I'm going to leave you with that as the introduction. When we get back, so if you didn't follow this, don't worry about it. We're going to do this again. So when we get back from lunch, I'm going to go through a bunch of stuff on the syntax. Then we're going to go slower. We're going to build a project from scratch. That's going to be very similar. There's maybe a little bit more functionality. Get the text, set the text, do a bunch of stuff to GUI components, and see how the language works. But I really need to like show you some syntax stuff that's going to take, it's going to be a little time consuming. So we'll wait till after lunch on that. So I'm going to stop this recording. Stop.